Today we're going to continue our study in geometry by talking about perimeter and area of polygons. We're going to start with perimeter. So perimeter is the measure around a geometric figure. Now the way that you would determine the perimeter of a certain geometric figure is to determine each measurement of the sides and then add them all together. So for this first example, find the perimeter of the triangle below. We have two of the sides of the triangle, but we have one side that's missing, that's x. So how do we determine what that side is? Well, because this triangle is a right triangle, we can use the Pythagorean theorem to determine the value of x. So this would be x squared plus 24 squared equals 26 squared. And then we'll solve for x. So we have x squared plus 576 equals 676. Subtract 576 from both sides, and we get x squared equals 100, which means x is equal to 10. Now that we found what x is equal to, we can find the perimeter of the triangle. Remember, the perimeter is the distance around that geometric figure, so we have to add all of the sides. So the perimeter here is going to be 10 plus 24 plus 26, which is equal to 60. So we'd say the perimeter of this triangle is 60 units. Now let's talk about area. Now with area, there are a number of formulas that are given to you for reference for the different geometric figures. Now the area is the measure of the space inside of a geometric figure. So here are the formulas. So we've got formulas for the area of a square, the area of a rectangle, parallelogram, triangle, and trapezoid. Now for a square, S represents the length of a side. And since it is a square, both sides will be equal to each other. So the area inside of that is S times S, or S squared. For a rectangle, you may have also learned this previously as length times width. Here we're going to use the terms base and height. So B stands for base, H stands for height. Now notice here that the base happens to be the length, and the height, which happens to be the width, those are perpendicular to each other. And as we continue with these area formulas, you'll notice that the base and the height are always perpendicular. So now look at a parallelogram. See here that the base, that's along the top or along the bottom, that distance is perpendicular to the height, which is not just the measure of the side of the parallelogram, but it is the measurement that is perpendicular to both bases. All right, next we have a triangle. That's 1/2 base times height. And again, you can see here that the height is perpendicular to the base. All right, lastly, we have a trapezoid. And this one, unlike a parallelogram, has two bases that have different measures. So we have base 1 and base 2, B1, B2. And then we have the height, which is, again, perpendicular to both bases. All right, let's look at example 2. It says to find the area of the figure below. Now we can see here we have a parallelogram. And because it is a parallelogram, the area formula is going to be the base times the height. Now you have 3 pieces of information here. So you want to make sure that you are working with the base and the height. So in this case, remember that we're looking for 2 measurements that are perpendicular to each other. Now, the height, which is 5 inches, is perpendicular to the base, which is 10 inches. So that 6 inches that's given to you is unnecessary, at least in terms of finding the area of this figure. We only needed the base and the height. So this will be 10 times 5, which is equal to 50, and since this is an area, we will say this is 50 square inches for our answer. All right, example 3. Find the value of x if the figure below has an area of 28 square units. Now again, there's a lot of information here. We'll pick out the information we actually need, but before we do that, we have to first look at what kind of a geometric figure we have. Here we can see that we have a trapezoid. So let's write down the formula for the area of a trapezoid. Now we're told that the area is 28 units squared. Now we have to find the value of x. X happens to be one of the bases. The other base is 8, and the height, which is perpendicular to both bases, is 4. So let's fill in everything we know. So the area is 28, the height is 4, and one of the bases is 8. The other base is x, so I'm going to write x in there. All right, let's simplify this from here. So 1/2 times 4 simplifies down to 2. And then we can distribute that 2, so we have 2x plus 16 on the right. Subtract 16 from both sides, we end up with 12. So 2x is equal to 12, divide both sides by 2, and we get x is equal to 6. So in this trapezoid, the x that's represented there must have a value of 6 if this trapezoid has an area of 28 square units. All right, so now that we've talked about areas of polygons, now we're going to continue by talking about area of what we call composites. Now, to find the area of composites, you will divide the area into recognizable figures, or figures in which you know how to find the area, and then find the areas of each figure, and then add up all the areas. So when we're talking about composite figures, we're talking about figures that are composed of multiple different types of figures. It could be a triangle with a square, and they are combined together. With composites, there can be multiple ways to go about dividing up its area into figures that you can recognize. Let's take a look at this last example. Find the area of the composite figure below. So you can see here that there are at least 2 ways of coming up with multiple figures that you can find the areas of. One way to do this is I'm just going to go ahead and draw this dotted line here, and so I'm going to divide it into 2 rectangles. And then, since I can find the area of a rectangle, I'll find the area of each rectangle and add them up. Now you could also draw a dotted line going horizontally to also have 2 rectangles. All right, so now let's take a look at what we have. So we can easily find that on the second rectangle, the larger one, we have 2 measurements, 7 and 10. Now on the smaller one, it's not as obvious what the measurements are here. We have one side that's 2, but what is the measurement of the other side? Well, since we know that the measure of the entire length there at the top is 12, and we know that 7 of those units are accounted for by the second rectangle, then if I do 12 minus 7, that means that this length must be 5. Now that we have that, we can find the area of the smaller rectangle. So that's going to be base times height, which is 5 times 2. And then that's equal to 10. And now we can find the area of the second rectangle. Again, base times height, which in this case would be 7 times 10, which is equal to 70. Now to find the area of the entire thing, we're going to add these areas together. So we have an area of 10 plus 70, which is equal to 80. So the area of this composite figure is 80 square units.